Hi everyone and welcome to the new video. In my previous video I did several experiments with the Tesla coil. I was able to play music using the high voltage sparks, and it was also nice to see the glow of the krypton gas ball. And then I saw a Tesla coil on Amazon for only about $10, and I was curious what can we do with that. In this video I will show how this Tesla coil works, how the manufacturer was able to reduce the costs, and what fun experiments we can do with that. And I will also compare it with the more expensive model. It should be fun, let's get into it. So I did an order on Amazon and finally the package has arrived, and let's see what we can get. As we can see, the Tesla coil is really small, and also let's see how the manufacturers cut the corner and made so low price. Let's see what is inside. So first we can see two things where the manufacturer cuts the cost. First we need to assemble this board ourselves. It's not pre-assembled, so we need to solder it. And second, as we can see, the power supply is also not included, so you will also need to have a power supply. We can see a parts list, apparently in Chinese. I don't read Chinese, but from this list I can guess that we have two resistors, two LEDs, two coils and two capacitors, so it should be simple. And this is the schematic and the manual. As we can see, it's very clear. If you want, you can pause the video and read it. So here we can see a power input, we can see one transistor, we can see two LEDs, and we can see Tesla coil that apparently has 350 turns. This is the Tesla coil. And the idea of the Tesla coil that it is a resonance transformer, so it has a small amount of primary coil and large amount on the secondary coil. Primary coil is connected to the transistor, and here is the secondary coil. And apparently the primary coil is connected to the base of the transformer, so the circuit will work as a resonance. And the secondary coil is only 2-3 turns. And interestingly, we can connect the audio speaker to it, so we will be able probably to add the audio modulation. As we can see, here is a voltage divider, and the audio input is connected to this transistor, so probably it will allow us to modulate the spark with the audio. And let's see how it works. Let's start with the assembly. These are all the components we have. As a rule of thumb, it is recommended to start with the smaller components, so it will be easier to mount them. And I can start with the resistors. I can also verify the resistors. I almost never remember these color lines. As we can see, all components are described here, so it's pretty easy to mount them. And now we can start soldering. As we can see, the process is easy, it is not a rocket science. Just keep in mind that this Tesla coil is cheap, but if you don't have a soldering iron, you have to buy it. But it is a good educational experience as well if you never did it yourself. It's fun to test. This board is small and simple, so it is good for beginners. Okay, out of camera I soldered other components, and this is what we get. As we can see, it is a pretty simple board. We have these two transistors, we have a Tesla coil, we have an audio input, we have a power supply, we have two LEDs. And interestingly, as we can see, one of the LEDs is connected to the secondary coil, so we will see that its brightness is changing when the load is changing. The assembly itself is simple, all components are labeled, so we only need to put them and solder them. The only thing is, if the LED does not work, then probably you need to reverse the polarity, because for LED anode and cathode are important. Another thing is this electrolytic capacitor. For the electrolytic capacitor we also need to know the polarity. It's marked as a minus. For the primary coil it is recommended to have 2-3 turns. If you have less turns you will have higher voltage, but you will also have a higher current, so your transistor will be probably a bit more hot. And I also used a bit of super glue to fix this coil. And technically that's it. As you can see, the assembly is pretty easy. Let's see how it works. As we can see on the power input, the recommended voltage is 15 to 24 volts. I'm using this universal power supply. It has adjustable voltage from 12 volts to 24. And here we can also have this small neon bulb that we will use for a test. I connected a power supply, and it may be not very visible, but we see a very small spark. Now it works with 12 volts. So as we can see, the Tesla coil can work with all different voltages. As a first test, we can see that the Tesla coil is really generating high electromagnetic field. And as we can see, even from several centimeters, we can see the glow. As we can see, this neon bulb is not connected, but it glows pretty bright. Interestingly, we can touch this spark. It's probably several thousand volts, but despite this, it's a very high frequency. It's not dangerous, but I feel a heat, so I can a bit burn my skin if I do it for a long time. And I will continue the experiments in the evening when it's dark. Okay, it became dark and we can continue our test. And first is the lowest voltage. This is 12 volts now. So this is the spark with the lower voltage. This is 12 volts on the power supply. And as we can see, we can observe the glow of the neon light bulb. As I mentioned before, this spark is pretty hot. As we can see, it can easily light the match. I'm not sure if it can burn the wood, but I can see a bit of smoke, so it's definitely burning. Before we could see how the neon light bulb glows in the electromagnetic field. And now I can also show different colors. As we can see, I have neon bulbs with different gases inside, and it looks pretty beautiful. They all glow together. As we can see, they are not connected. It is also fun to see that when I touch the wire with the finger, it glows brighter. Apparently my finger works as an antenna. I will try to show it closer to the camera. I can also try to show the micro lens of the spark with the high resolution. And then we can also see in the high resolution how the neon lights are glowing. As a next experiment with this Tesla coil, I will try to show a glow of the noble gas. This bowl is filled with the gas krypton, and this gas can glow with the high intensity electromagnetic field. As we can see, it's pretty interesting. This plasma is following the coil. Now I can increase the voltage and see if there will be any difference in the intensity. It's pretty interesting to see how this plasma is following my hand. When I touch the finger, it's different. It is also interesting to see that now there is no spark, and apparently all energy is going to this krypton ball. We can see that the ball turns off and the spark immediately turns on, so it's pretty interesting. And when I touch the ball, it immediately moves to a new position. As a bonus for viewers patient enough to view until this point, I will show how the noble gases glow in the Tesla coil electromagnetic field. And here I have 5 types of gases. This is xenon, this is krypton, this is neon, this is helium, and this is argon. Obviously without electromagnetic field it looks the same, but when I put it near the Tesla coil, we immediately see that it began to glow. And this looks pretty beautiful. So this is the argon gas. The helium has a different color and a bit different intensity. The next gas is neon. Probably people know the neon gas because of the neon lights. This is a krypton gas that we already see before in my bowl. And this is xenon, and then you can see its color is different. I can try to put it in parallel. It's also interesting to see that the intensity is different. I can try to put more gases at the same time so we can see the difference. So now we can see all the gases glowing at the same time. And interestingly, the difference is brightness is not so high. So this is the minimum voltage 12 volts and this is maximum voltage 22 volts. As we can see, there is not so big difference. I prefer to run it on the minimum voltage, otherwise the transistor becomes too hot. This one now, for example, I can barely touch it. And now let's go forward and I will try to play music with the Tesla coil. As the last test in this video, I will show how this Tesla coil can play music. As we can see, this Tesla coil has the audio input, but the problem is that most of modern devices don't have linear output. So for this test, I will be using this simple Bluetooth adapter that allows me to connect my phone. So I'm using a standard audio cable. This adapter works easy. When I turn it on, it will appear as a Bluetooth speaker. And as we can see, when the adapter is turned on, a new Bluetooth device appeared. And now I can use this Tesla coil as a Bluetooth speaker. Let's see how it works. But when the speaker is connected, I can just play the audio or video, for example, from the YouTube. And this music will be played. As we can see, it's not really high quality audio, but let's find some more tracks. Now I'm trying to play some old music from my phone. And maybe it is hearable, but it is very silent, so I can barely hear it. But technically it works, it is interesting. Okay, as the last part of this video, I can show two alternatives for this Tesla coil. As we can see, that is a nice Tesla coil and it works well and that we can do some fun stuff with it. But I can show two alternatives that also works. And the first one is this bigger coil. It actually like its bigger brother, it's the same idea. As we can see, it is also a simple design with probably one or two transistors. But there are some advantages. First, it is already assembled, you don't need to solder it. Second, it has a bigger heatsink and a fan inside. The top of this Tesla coil was slightly damaged by post, so I fixed it with the glue. And it is a bit more powerful, but surprisingly it is not drastically powerful, but I can show now how it works. This Tesla coil has an interesting hardware glitch. To run it, I need to touch this base, otherwise it does not start. Probably it needs a better ground. As we can see, it is generally the same idea. I can put a neon bulb and it will glow in my hand, but as we can see, the distance is bigger, so this Tesla coil is more powerful. This Tesla coil also has audio input. It is also safe. I can touch the spark and I feel a heat, but it's not really dangerous. I can also light the krypton ball. This Tesla coil is a bit more powerful, but the price is about 10 times higher. So the first small coil I reviewed, it has a price range $5–10. This is probably $50 to $100 depending on the store. They are available on Amazon or eBay, so you can check it yourself. And this is the second alternative in about the same price range. It's about $50. This is a musical Tesla coil. It has a Bluetooth included. You can see this blue LED blinking. And this Tesla coil can switch between the music mode and the spark mode. Spark works like this. I will try to show it right now. Interestingly, it's a different design, so it works only in the pulse mode. So it's a bit different. The first Tesla coil works in a continuous mode, and I think the first one is more suitable for physics experiments. This works only in the pulse mode, so it prevents the transistors from overheating. And it is interesting to see how it works as well. It is also safe to touch these sparks, and they are even not hot. In my personal opinion, I think it's more like for a party trick to show some loud noises and some sparks. But if you are more interested in some physics experiments, Tesla coil with a continuous mode can be more interesting, but of course it depends on you, it depends on what you want. And that's it for this video. Thanks for watching. If you enjoyed it, feel free to press like and subscribe to see more content like this. If you want to see a review of other Tesla coils, write in the comments below and maybe I will make it in the future. Also feel free to visit my Patreon page if you want to support this channel. This support allows me to buy things like this for testing, and you may also get early notifications about new videos. Thanks for watching and see you next time.